At first glance, small batch production and large-scale manufacturing can look very similar. The development phases, timelines, and terminology often appear almost identical on paper. But in reality, the journey is very different. Behind every small batch product are unique trade-offs, sourcing risks, production limitations, and engineering decisions that many teams only discover once development is already underway. Most hardware projects still follow the same core phases: PRD, EVT, DVT, PVT, and eventually mass production. At Create, these phases are approached through focused development modules with clearly defined deliverables and objectives. But what truly changes between small batch and large-scale manufacturing is how these phases behave under real production conditions. So in this video, let's explore some of the most important realities behind small batch production and why understanding them early can prevent costly surprises later on.
One of the biggest misconceptions in product development is believing that changes stay equally manageable throughout a project. They don't. In every hardware project, changes affect time, cost, and momentum. But the later those changes happen, the more disruptive they become. A small adjustment during the early PRD or EVT phase may only cost days. The same adjustment during DVT or PVT can suddenly trigger tooling revisions, new testing cycles, supplier delays, and major cost increases. And once tooling investments are made, many decisions become effectively locked in. This is where inexperienced teams, especially startups entering small batch production for the first time, often run into trouble. Early planning and validation can feel slow or expensive, creating pressure to move faster. But strong development teams invest heavily upfront for a reason. They spend more time verifying engineering decisions, reviewing manufacturability, and reducing unknowns before production complexity begins compounding. Because the cheapest time to solve a problem is always earlier in development. And this is also why low upfront pricing from engineering partners can sometimes become misleading. Fast early progress may look attractive until hidden revisions, delays, and unexpected costs begin surfacing later, when changing direction is no longer realistic. That's why careful planning and rigorous validation are not unnecessary overhead. They are what prevent projects from becoming expensive production traps later on.
Another major challenge in small batch production is component sourcing. We often call this the bargain mirage. Online sourcing platforms can sometimes show pricing that looks dramatically lower than established supply chains. Naturally, many teams ask, why are we paying more elsewhere? But extremely low pricing often comes with hidden trade-offs. Some parts may be clearance stock, discontinued components, or short-term availability deals. That may work for a prototype, until the next production run suddenly requires a redesign because the component no longer exists. In other cases, the risk is quality consistency. Low-cost components may come from gray market channels, rejected factory batches, or suppliers without reliable quality control. And while parts may appear functional initially, reliability problems often only appear later under stress, heat, or larger production volumes. Experienced production teams therefore evaluate much more than unit price alone. They look at supplier stability, long-term availability, traceability, consistency, and reliability. Because in manufacturing, the cheapest component on paper can easily become the most expensive decision later in the project.
Another important reality of small batch production is unit pricing. Many people compare their product to a mass market competitor and ask, why is our unit price so much higher? The answer usually comes down to fixed costs. Before a single product is built, factories already invest significant engineering time and resources into tooling, machine setup, fixtures, testing procedures, and supplier coordination. There are also non-recurring engineering costs, certifications, reliability testing, and supply chain setup. These costs exist whether you produce 1,000 units or 100,000. Large-scale manufacturers can spread those costs across enormous production volumes, dramatically lowering the price per unit. Small batch production simply has fewer units available to absorb those expenses. That's why smaller brands rarely compete successfully on price alone. Instead, successful small batch products usually win through differentiation, through innovation, customization, user experience, product quality, or by solving problems the mass market does not address.
One of the least understood realities of small batch production is production yield. Yield refers to how many products successfully pass manufacturing and quality control without requiring rework or being scrapped. Large manufacturers invest heavily into improving yield rates. Before mass production begins, they often build hundreds or even thousands of trial units to uncover hidden assembly issues, supplier inconsistencies, tolerance problems, and long-term reliability risks. Small batch production works very differently. Smaller teams usually have fewer prototypes, fewer validation units, and far less budget for extensive pre-production testing. That means there are simply fewer opportunities to uncover every hidden issue before products reach the market. As a result, first-run yield rates in small batch production are naturally lower than what large-scale manufacturers typically achieve, not because teams are careless, but because they operate with very different scale and resources. The good news is that yield rates usually improve quickly as manufacturing processes become more refined and stable over time. And that's perhaps the most important takeaway from small batch production. Success doesn't come from ignoring the realities of manufacturing. It comes from understanding them early, planning around them properly, and building products with realistic expectations from the start.